So today we are working on a 2014 Range Rover Evoque 2-liter 4-cylinder turbocharged, and the customer brought it to me because he wanted me to check and see why it's overheating. They're suspecting a head gasket issue and wanted me to find out if I can see anything for sure. I've already looked at it just a little bit, so I wanted to pick up the camera and bring you guys along with what I am beginning to see. First and foremost, I did scan it. They had some misfire codes, nothing that was current, and I noticed pulling it in and out of the shop that it didn't misfire at all for me. Now, as far as what my plan of attack is, to do my usual scoping the pressure in the coolant system and try to sync it with a cylinder firing order to find out if we have a dead hole as far as head gasket sealing based on compressions. So first things first that I'm gonna do, as I always do when checking for failed head gaskets, crank no start. I got the injectors unplugged. I'll run relative compression while monitoring the pressures in the coolant system and syncing with cylinder 1. And I'll go ahead and crank it, get you a shot of that. Okay, so I'll go ahead and get ready to crank, and I'll get you guys focused up there. Okay, and I will do a second continuous crank. And maybe even a third, just to show you. Okay, so here we have those 3 cranking states, and as far as channels go, the blue is going to be the relative compression, red is going to be cylinder 1 ignition sync, and the green is going to be the coolant pressure. I want you to, I did this once off camera, and it is not what I was expecting to see, and it's not what I usually see when looking for and find a failed head gasket. I want you to pay attention to the green trace, which is the coolant pressure. See how it almost looks like a stairway? Each time I had cranking being continuous and going, the pressure rose from here to here. Obviously here to here it rose. It stayed until I cranked again, and then it rose up again. It stayed, and then I cranked it, and it rose up again. Pressure in the coolant system keeps rising as the engine turns over and I guess builds pressure from compression pressure into the coolant system. There you can see a little better scaled. As far as what is confusing is there is not one particular cylinder that seems to be singled out as far as a true failed gasket area. Here zoomed in, I'll get some of the rulers. And here's 1, 3, 4, 2, back to 1. And each time all of them had gone up on compression, there was not one that spiked up crazy amount for me to be able to be like, okay, cylinder 1 is the problematic area of the head gasket, sealing or or a possibility of area. So there's not one identifiable place where we can determine a fault. The only thing we know is that pressure continuously rises. Just to get an example of a reference number, if I put my marker there, so far on 3 cranks, it's about 6.5 psi that it's raised it. Now I don't know exactly how to make a call on this, just because I've not seen this. I can't specifically say that there is one single cylinder that is standing out. Like I said, I've not seen this. This is new to me as far as capturing and seeing pressure increase continuous. So now, because I've not ever run into capturing a situation like this, what I want to do is simply crank it over with all 4 spark plugs removed and see what that is going to look like in the coolant system compared to what we have here. We're going to eliminate the ability to build compression pressure in all cylinders and let that compression bleed out and escape through the spark plug holes. And I want to see what the coolant pressure system looks like then, with no compression pressure being able to be built up. Okay, so now I'll crank with no spark plugs installed. Okay, so here's a good shot of what that looks like with no spark plugs installed and cranking over. As far as coolant pressure in the system, it stays steady. There is no rise in pressure, no activity. So right off the bat, I do know that there is an issue with compression pressure related with coolant pressure rising. As far as how or what or from what, I still don't know if it's a whole warped head or what, because like I said, I'm not seeing it coming from one particular cylinder. And so that's what I'm trying to wrap my head around, or figure out how it's a continuous build in pressure, and what I'm seeing with all 4 spark plugs installed. So I'm not sure how well you can see that. I'm looking down into the cylinder through the spark plug hole of number 3 right now, and there's some sort of fluid speckling. Hopefully you can see or tell on top of the piston there in that center hole. This is cylinder number 2. You can see the fluid speckling again, and I can't get it on camera, but cylinders 1 and 4 do not have that speckling. So based on what I'm seeing here, with there being no pressure buildup, with no spark plugs installed, and then based on what I saw physically down the spark plug holes in the cylinders, with 2 and 3 having what looks like a fluid in there, I decided to install spark plugs 1 and 4, leave 2 and 3 out, and then go ahead and crank it and see if this stays the same or what. now we'll crank with cylinders 1 and 4. And that is what that looks like. No effect and no change with cylinders 1 and 4 sealed up and building compression. You can also see here's 1, so 1 right there, and then 3, 4, 2 is missing, back to 1. So we're building compression on 1 and 4, and our coolant pressure is staying the same. So my next step right now is I removed 1 and 4, and I'm only sealing up cylinder number 2 at first. I want to see what these two look like individually, if they make any changes with the coolant pressure. We'll now crank with cylinder number 2 sealed up. Okay, so here is that capture of cylinder 2 sealed up. We obviously have activity going on now. There's a change in pressure in the coolant system, and it seems to be some sort of repetitive oscillation. Now, one thing to keep in mind right now, as far as just the direction of travel, I did switch sensors just for scaling purposes, and on this one, it's the one I usually use for head gasket testing, and positive pressure in the system makes the sensor travel down. Keep that in mind. That is why on this change of pressure activity, it's traveling downward, but that is positive build-up pressure there that we are now having. So between 1 and 4 sealed up, no change. Remove those, install and seal up cylinder 2. We now have a change. What I'm going to do before I analyze this one, I'm going to remove, which I actually already have, remove 2, move it over, seal up number 3 as the only one, crank it and see what that looks like, capture it, and then I'll analyze both of them separately. Okay, so we will crank with cylinder 3 sealed up. So here we have both captures for cylinder 2 and cylinder 3. I'm going to just quickly go over that just to show you what that looked like, since this is the steps that I was going through in order to try to identify what was going on with the 2 of those cylinders. So this here is cylinder 2 and this here is cylinder 3, both on the coolant pressure. You can see oscillations along with buildup of coolant pressure, a rise in coolant pressure in the system. 2 seems to be like it maybe contributes a little bit more, since these are being isolated. But just to show you, so we are synced on number 1, so 1, 3, 4, 2, rise in compression because it's the only one that's sealed, and then back to 1. And so if we follow that, it's 1, 3, 4, 2, right at 2 compression. It changes that direction, it shoots positive pressure in the system, and it drives that signal down. we go to number 3, so again, synced off 1, 3, 4, 2. So 3 is the only one sealed up. And that's what coolant pressure looks like with the firing orders. 1, 3, 4, 2. Right at 3, compression, top dead center, it spikes that positive pressure in the system, shoots that signal down. Now with both of these, I was just going to this extent of isolating and breaking the two apart to attempt to see what was the contributing factor between the two, because I was basically chasing what I've always up to this point have seen, where a single cylinder is a contributing faulted issue and it creates one singular spike that's identifiable. This one was not, and I was chasing for what I've known until seeing this and being intrigued, and which is why I went to this extent of cranking each one of cylinders 2 and 3 individually and seeing how they affected the coolant system. We can clearly see that it looks like number 2 is probably the higher contributor as far as pressure based off of that. So it's a little bit of an overkill situation, but it's more to satisfy my curiosity as to why the pressure was being built up continuous through cranking and not being identifiable. Now I know why. It's because 2 are the contributing faulted cylinders into the coolant system, and now we know what to look for when opening up the cylinder head if we do so. Okay, so I just got the head removed. Here are all the components for the valve train, and then there's the cylinder head. But before we get a good detailed look there, I wanted to show you the first look after pulling it off. Obviously, don't mind that happened as I was disassembling. Removed the spark plug, and since I knew I was pulling the head off, the porcelain ended up falling down, which is fine, no problem. But obviously, we have coolant in the number 2 and number 3, which were the ones that were showing us problems earlier in the scope capture. So I haven't removed the head gasket yet, but I am betting that there's going to be some deformation or something. You can almost tell the condition's not probably the best of the head gasket, but I'll get it removed and then take another look at it. Okay, so the one thing I noticed right off the bat, so here's the top view. So this is 2 and this is 3 and that's 4. Now it's gonna be hard on camera, but if we look at this area between 3 and 4 of the head gasket, it's really sandwiched tight there. And then if you then look at here's 2 and 3, there is a portion towards here where it's lifted, and off camera I can actually see through. It's hard to tell, but see, it's kind of lifted right there. So that is where we have it split, and that's where the two cylinders are sharing the pressure buildup in the coolant system. Okay, so just a quick referencing point that I am making sure to take a look at, being that it seemed to have gotten hot. I want to check the cylinder head straightness or flatness, whatever you want to call it. And as far as the spec that they are giving you is 0.1 millimeter, which converted is just under 4 thousandths. So this is where I'm going to check those reference points, and I'm going to show you with the 3,000 feeler gauge. This is in between 2 and 3, so that clearly goes in. It goes in there as well, and there. You don't usually expect them there, obviously. And then we go that way. That one goes, and that one goes. Goes, goes, goes. It goes, goes. It goes up to about that point and about that point. So even this way, it's going, the 3,000ths. And this is about the only spot where it does not go through. So, in the crisscross areas and the straight down the middle, the 3,000ths fits in a lot of places, and even on this edge, which is on the exhaust side, it does go. On the intake, it does not. Now, to show you, this one is the 5,000ths. And even the 5,000ths does go. There we go. In some of these areas. So we have at least a 5,000ths of warpage. Right there. Going on. And this is 2, this is 3, as far as the cylinders. So that's the 5,000ths. And even the 5 goes through in here in some areas on the exhaust side. Obviously I'm not going to show the intake side. If 3 didn't go, 5's not going to go. And I've already cleaned enough of the area, the gasket material and stuff, as I normally would do and take these measurements, but so it's not being lifted by any gasket material or whatever. It does have some warpness. This will need to be sent to the machine shop and see if what amount he can take off to make this right, or at least usable. Now obviously if we have warpness here in the head, I always want to double check before going forward as well what the cylinder block looks like. So here's the block, and I've cleaned off a little bit enough with the eraser to try to get a same measurement. I've also backed off the crank to lower the piston. You can see I marked it, but drop it down below the deck in order to have that not interfere with the straight edge. So I am going with the 3000s. Okay, if you can see, here's the 3000s, and it just barely starts to go. Not here, and this is between 2 and 3. Angled, nothing. So here is the cylinder head back from the machine shop. Clearly it's been milled now to where it's not warped and it's straight, good and flat. I did ask him about how much he had to take off to get it as true or to the point of where it's at, and he did say it took 5,000. So I guess that was the max that it was warped, like what we were about measuring with the feeler gauge. With that said, I was looking at it, and then I know I had shown you the head gasket area where the layers kind of separated in between 2 and 3. But I would probably venture to say that it's not necessarily, as far as maybe occurrence or order of occurrences, not necessarily a head gasket issue. I think that possibly is just a result of it. You know, the adjacent cylinder, whichever one it was, you could see it was fully squished, and the layers had not split open yet. Possibly, I'm thinking that there was an overheat situation maybe at first, and then warped the head, and then being that it's warped, then the clamping was not fully squishing the head gasket, particularly in that area, and also probably more along the face or the exhaust side, which I believe was the one that was more warped. And then so being that it's not fully sandwiched and clamped, it with combustion pressure or compression pressure, it started to allow it to start to creep over in this area and started to probably unstick or unlayer or separate the layers of the head gasket. And that's what we saw. And then as far as why it was going into the coolant system, clearly there is a coolant port there. So I'm just trying to rationalize with what we saw in physical form. Believe that it was the head warped from an overheat condition. Result of it was the head gasket not sealing as it should because not being clamped down, and then the pressure going into the coolant system somewhere in this region in this area as well, possibly on the exhaust end. So probably more than need to even think about or consider, but it's just what I like to try to rationalize, especially when I'm going back together with something, trying to make sure everything is aligned or things are figured out to a point where you are comfortable reassembling and, you know, investing time and money in it. Along with that, got all the parts, new gasket, bolts, timing components, even phasers, and cleaned up the block. bolt holes all blown out, and ready for reassembly. After that, I will most likely probably just do a quick after capture of the coolant system while cranking. Okay, so got everything completed and put back together. One word of advice: anytime you do timing work on these, do go into the engine computer and in the service function portion of the power control module, the PCM. Go ahead and do a reset adaptation values or reset all adaptations, something to that extent. Basically, it's going to relearn its trigger positioning point in the new position as opposed to what it remembered it at previously. Along with that, I am set up to just quickly do the cranking with measuring the pressure, and we can get going. I've disabled the coils for a crank no start. I've actually set up for relative compression measurement also, just to get you a good reference. So here we are. This is that capture that we did. I ended up putting the relative compression just for a reference point of in time to know when we were cranking, just because it's also a little bit of movement in the coolant pressure trace there. And then just basically you can tell that there's nothing crazy as far as pressure spikes or anything, and a little bit of hiccup there and then there. So with the starting and ending, bigger oscillation, but this is still very minimum. I've actually got this scaled up ×4 on the green trace to be able to see some sort of activity or oscillation or movement in the coolant system. So there is very slight activity going on, just proving that we are rotating and moving the water pump during cranking, as opposed to this is just steady with the sensor on. So no more failed head gasket symptom here. That has been cured, and no more pressurizing of the coolant system. Now this obviously clearly couldn't have been done within the first 5 minutes of the first capture with the coolant pressure system and syncing it, or as simple as removing spark plugs if you were having a hunch about a head gasket and being able to literally physically see some sort of coolant trace in one of the cylinders. I understand this is probably some sort of overkill, which could be considered that, but on the other hand, this is where I can control the situation with possibly knowing that it's going to be a head gasket and seeing what I can find. So part of the reason why I did it was to basically educate myself because of the weird stair-step increase in pressure that I was seeing in the coolant system, which I've not run into before. So I spent the time that I did in trying to break it down and break it apart and isolate it, and seeing why or how the two, or how individual cylinders could be the affecting or could be the faulted cylinder, and trying to find it that way, and it's why I went the way I did. And now I've learned that a big fear of mine that I was having was, what if we're dealing with a cracked head? I don't want to, commit to, or, sell a job and can't be completed because the head's cracked. That was basically one of my big concern and fear as to why I broke it down as to the way I did, because I wanted to try to find a faulted individual cylinder, and I ended up finding two. But at that point, I could actually literally isolate it to two different ones individually. But then when those two are combined, both sealing, they double the increase in pressure, which is why I was looking the way it was doing. So it's kind of a good way of finding two cylinders from a bad head gasket, or multiple cylinders from a warped head. That was something that I kind of learned, is that basically it was more due to a warped head. So we're kind of seeing the effects of rise in pressure because of a warped head. It's basically why I ended up concluding from all this elaborate, long-winded testing that I did. But I educated myself. I answered questions that I had for myself, and now I can take that and put it in back of my head for future reference. Again, I always will try to portray, make this a different situation. Yes, this was a 4-cylinder inline 4, easy to see every spark plug and so on and so forth, all on one head. Change the game, change the scenario. What if it's a V6 where you can't get to the back head, or there's two different heads creating pressure, this and that, or a bigger engine or a more expensive engine, or all of that. This is why I educate myself and break things down to the point that I do. I hope to not bore people when I portray this. It's more of information for you guys to see in person. If you're not doing it, you can at least see what I saw when I did it. So hope that's part of a takeaway that you get out of this, and it's why I do this also.